Okay, so as Julie mentioned, I'm going to be talking about personal reviews, and I have an example of how fencing with an APE, which is different than foil, I'll explain later, how that plays in to illustrate how personal reviews make you better. That's where it ties in. Okay, so the goal of the presentation is to teach you how to, or show you the best practices for how to do an effective personal review. Now, I'm saying this not in terms of software, but in terms of everything that suffers from what I would call rework. It'd be great if you did things right the first time and it was perfect, but software especially is very hostile when it comes to rework. So this is where it pays off the most, but I'll try to present this in general. So same applies if you write requirements with mistakes. But anyway, to get that effective personal review, there's some prerequisites. So to do that effective personal review, you have to be able to follow a personal review process. I'll explain that. It's very simple. And you have to be able to get your hands on a review checklist with good checklist items. And there be the crux. So to get good checklist items, you have to know how to create them because you don't get them and buy them online. You make them about your problems. And so how do you make a good checklist item? By logging mistakes with good descriptions. So I got to work backwards, and I'll start from the top and work through these to give you all the pieces you need to be able to hold personal reviews that rock the Casbah. Now, along the way, I'll also share a couple of tips on how to be a better fencer. And the first tip from here is never take both feet off the ground when you're fencing. It's always a bad idea. It looks really cool on pictures. You'll see it on videos. But as soon as both feet leave the ground, you can't control your motion. And the other fencer will then take advantage of that and score a point because you can't stop where you're going. All right. So a little bit of background before we get into those pieces I just talked about. What's a mistake? I'm not going to make any assumptions about your background. I want to explain the terms I'm going to be using. So a mistake is a change you must make after you thought you were done with some product. An example of that would be you made some requirements and you put it out for peer review, and a peer reviewer comes back and says, Brad, you forgot this section. And you go, oh, shoot. Well, there you go. You're off modifying the requirements that you thought you were done with. And so that additional the work you're doing after someone says they found a problem, that's a mistake. All right, so that's just one illustration. Another one would be if you have software and you try to test it and it doesn't work right, you're now go modifying the code. That's now because of a mistake you found. So review, inspection, fail test, all of those are ways to find mistakes. And oftentimes, either the product doesn't work properly or it's hard to use, hard to be installed, the documentation's messed up and makes users cause errors, all kinds of problems. But all those are mistakes. And the whole idea behind it is that after you make the product, if you have to go back and touch it, then you are fixing a mistake. Now, here's two scenarios. So one of them, the first one here, you have an individual who finds a mistake early on in their product and their work. So say it's a requirement. So they do a personal review on the requirements, they find the mistake, and they fix it. It takes a few minutes, the only person involved is them, and there's no one else going on, right? So very simple, straightforward. Now imagine if that requirement mistake was not found, and the customer using the product in the field finds the mistake. It's the wrong behavior because the requirement was describing an incorrect behavior, and no one caught it. So during acceptance testing, imagine an aircraft trying to drop a stick of bombs on a test range, and they hit the button to drop the stick of bombs, and instead the Sidewinder powers up. Okay, there's a problem there. So they write it up and they give it to the organization that writes software for that aircraft. That organization then takes that problem, description of the problem from the pilot, and routes it through to one of the subgroups trying to figure out, well, is it a problem with hardware, with software, requirements, what is it? And so they drive it down and someone has to spend time trying to figure it out, and eventually comes to someone's lap where they go and dive in and find out where the problem is and they fix it. In my example, if a bad requirement, You'll go to the software team, hey, we wrote software perfectly. It's doing exactly what the requirements say. And someone finally looks at the requirement and goes, oh my goodness. And they fix the requirement, which then causes the software to be rebuilt, retested, and then returned to the field for the pilot to do that same flight where he hits the button, trying to drop a stick of bombs, and the stick of bombs drops. Now, you know the first one doesn't cost very much, but think of all the costs in the second one. All those people, all that time since the pilot first hit the button and the wrong thing happened, everyone involved in this discussion on those 5 bullet points, all that is the cost of fixing that mistake. Tons of time, tons of money. So this is one of the benefits of trying to find mistakes early on in your process. Here's another illustration of it. You got 2 projects here, and one of the both have the same amount of green horizontally. That's the work being done, and the red is fixing something that they're trying to deliver. And so here at the first top, you have a team that does a bunch of work, and then they try to make it so it passes their acceptance tests, and they find all these problems and they're solving them all. You have to redo a bunch of work. This is classic of a hemorrhage in the testing mode. You never know when you're done until you finally get it good enough. Well, here in the second bar, they're doing some checking early on to see if they have any problems with their interim artifacts, like their requirements or the design or the code before it gets to test. And so they find some mistakes and they fix them, which then leaves fewer mistakes at the end. And there's always going to be mistakes. The trick is where you find them. And so they find a couple at the end. They don't have this massive hemorrhage. So they result in finishing early because they don't have as much red, not as much rework. And that's one of the benefits of finding mistakes early in the process. All right. So testing versus like reviews and inspections, we call those appraisals. You're appraising the product before you try to use it. So in testing, you have to detect there's something weird going on, some weird behavior that's not what you wanted. And then you have to go to that black box and say, what should it have been doing? And then you have to go inside the black box and figure out where in that black box is the mistake being, the bad behavior being caused. And then once you find that, you have to figure out, okay, so how do I change what's causing that bad behavior to be the right behavior? And all of that is what happens when you're trying to find and fix a problem found in testing. Well, that's a lot of time. So in reviews and inspections, you're looking at the interim product, you're looking at the requirements, you're looking at the design, you're looking at the code. And so when you or your peer reviewers find a problem, you're looking at the product and you say, here's where the mistake is, and here's why the mistake is there. Either you found it or someone else found it, but they can say, this shouldn't be like this, and they can explain it to you. And so then you go, oh, okay, all right, that's a mistake, or it's a misunderstanding. Either way, it's resolved quickly, and the author of the material can make a really good position to be able to come up with the right change to that broken product to make it right. And there's no hunting around trying to figure out where the problem's coming from. You're looking at the source of the problem. So right away, you can see that'd be beneficial to find all your mistakes in reviews and inspections. Here's some data from Xerox. This goes way back, but what I want you to focus on is these 2 boxes here that are in green, design reviews and code reviews. Now what you're seeing on this scale here is when you take all the time spent in design review and you divide it by the amount of mistakes found and fixed during design review, then it comes up with this number, which is the average time it takes to find and fix a problem in design review. So not just taking the actual time, but also including the time to fix a problem, but all the time where you're looking for a problem. That needs to be counted too. Still comes out to just 5 minutes per mistake. Code review, even shorter. Now these are, they're not, I would say they're not typical, but they're not atypical. These are unique to Xerox. I'm trying to show real data. Now compare those two. Single digit is again time in minutes to fix a mistake, given all the time fixing the problems and the overhead of looking for a problem. And then you compare those to these ones that are tests near the end, in red boxes, and realize that this is not a linear scale. This is a log scale. So you've got even at best case, a 6-to-1 ratio here between the design review time to fix a mistake versus test, which is 30. So you have 6-to-1, but it could be an extreme where you have a 700-to-1. between code review and system test. You just don't want to go here. You don't want to be here. You want to find the minimum mistakes you can here, and you want to find them all in other ways before you get to testing. Now, those boxes on the right, those are what we call early in the process, where you find a mistake early in the process. The mistakes at the end, you're finding a mistake that may have been built upon, like a bad requirement that had a good design and a good code written on it, had to be thrown away and redone because of the bad requirement. So the sooner you find the mistake from when you made it, the better. And that's why earlier in the process is better than later. Now, I don't think I described what TPI is. My bad. It's team process integration. It's a methodology we use. One of the techniques that we use for finding a mistake or fixing a mistake is you want to minimize the rework. You can't stop people from making mistakes, but you can minimize the rework. And so the best way to minimize the rework is two things, two principles. One is you fix it as soon as possible after you've made it. Obviously, you don't know when you made it, but if every time you drafted a document, you then spent some time immediately afterward looking for past mistakes you made in past documents, you are then taking a step to find it as soon as possible after you made it. Another part is you want the mistake fixed by whoever made the mistake. That way they know what they were thinking and what they should have done, and they can undo their mistake without taking a guess at what the author was thinking when they wrote that problem. So those two combined make it to minimal requirement of rework effort. And when you have those two going on, or you have a process, a set of steps in producing a product that takes into account these aspects, then you are automatically focusing on finding mistakes early in the process. You are, I'll explain to you in a few slides, logging the information on the mistakes you make. You use that data to improve your reviews and inspections and improving your process through modifying your checklist. More on that in a few slides. And when you're doing that, you're going to find mistakes earlier in your process. That means there's fewer mistakes to be found later, and you're going to be not hemorrhaging at the test phases if you have that in your process, your test step, and you'll be more likely to be able to deliver on time and under budget. So here's where fencing comes in. So let's have a fencer. Oh, I don't know. Let's call him Brad. So Brad's an APE fencer. APE is different from foil and cutlass in that APE, the entire body is a target. So in APE, you have two people facing each other with swords, and it's the first 1 to 5 touches. So, trying to draw blood, you're just trying to get the point of your APE onto the other person and do it 5 times before they can do it to you 5 times. So Brad comes home grousing from a weekend at a tournament, and he complained to his friends saying, yeah, I got out in the first round, but they were just lucky. And so he's grousing for half an hour, and after a couple of beers, someone tells him, hey, Brad, maybe you should figure out if you have the problem. So let's talk about Brad's world as whether he is conscious about some aspect of his fencing or unconscious about some aspect of his fencing. And let's also talk about whether Brad is competent at some aspect or incompetent at some aspect. Now, Brad doesn't know it, so unconsciously he is incompetent of some aspects of his fencing, and he is unaware of the mistakes he's making. Now, fencing's complicated, so let's talk about one little part of Brad's fencing. That is his stance. Now, APE, you have the entire body's a target. So if his foot is out here, like you see the picture, then it's a target. And if it's out close to the opponent will just reach down and touch his toe with the APE, and boom, the opponent gets a point. Now, Brad takes his friends. Brad didn't drink enough beer that he didn't forget the conversation. So he starts saying, okay, next match, I'm going to log all my touches that happened against me on my on the match I just got out of. And he might log other stuff too, because there's more aspects than just this one thing. But let's talk about the touches he had as mistakes. So he starts logging his mistakes in the next match, and now he becomes conscious of his incompetence. And he looks at his list of all the touches and he goes, 3/4 of the touches against me are on my right foot and shin. I can't believe it, 3/4 of them. He is now aware of a problem with his stance. So he goes, okay, let me do something about that. And so I'm going to change my stance. And so now he is consciously trying to improve his stance. Now, again, there are other aspects to fencing, but we'll just talk about this one aspect. So now he's working at having a better stance. And so he starts to move his foot back. And you can do that. Just shift your weight back and have his foot back. Now everybody has to reach a whole nother foot further to get to him, which brings them into his ape sooner. So he goes along doing this, and he finds that sure enough, when he gets in stance, he checks to see if his foot is forward, and if it is, he brings it back. And he keeps doing that. He gets in stance, he goes, shoot, it's forward. And he's doing that personal review, a checklist of sorts to make sure his stance is okay. And he keeps going through this. And sometimes he gets in his stance, he goes, oh, my foot's in the right place. Good. Another one, oh, it's in the right place. Good. And then he'll do it again. It's forward. He goes, oh, no, wait, bring it back. And he goes through this until finally he starts to put it in the right place all the time and doesn't repeat this mistake he's making. And that makes him, in that one aspect, unconscious about his stance being better. And he's doing his stance right the first time. And so then if someone comes around and says, Brad, you're going to your third Olympics as a fencer on the US team. That's phenomenal. How you do that? And Brad says, I just fence. He doesn't list off all the things he does, where his balance is and where his hands are and shoulders are, and he just does it right. And so now you're thinking, Brad, this is great. If I ever want to take up fencing, I will give you a call. But really, let's talk about fence. Let's take fencing out of the loop and talk about what we do. We work at desks with computers. And this whole concept applies to you, whatever you're doing, if you do it more than once. Brad has matches in fencing with APE. You have a set of requirements that you write for one release or for another, or you have a set of software you produce for one release or another. You have ditches you have to dig for one backyard or a front yard or another. If you do it over and over, you can start to become aware of your mistakes, and you can then, just by logging them, and then you can work on changing your process to make yourself better and not making those mistakes, or catching them sooner in your process. And eventually those mistakes, if you keep making them, you'll start to correct them while you're doing the work, and you'll be doing the ditches right the first time, the requirements right the first time, the design and the code right the first time. And that's how fencing comes into this. Now, when do you log a mistake? So the first thing you have to do is whatever your process is, whatever the steps you take in producing your product, you have to break it into steps where, think of it as one-way doors. Like I have example here for the creation of code, because code has the worst rework problems. And so I'm just going to illustrate it with one that people can relate to. So in this case here, by breaking into steps, you do your design work. You say, I'm done due diligence. I think my design is complete for this section I have to do. And then you go to design review. Now, I'm not talking, people look at this and say, this is waterfall. What are you doing? No, we're talking about a story point. Instead of trying to do it all and code it and then backfill the design and make sure it works before you do design. No, you simply break that couple 100 lines of code or 100 lines of code down and design that change. Design review on that simple design. Code that design, a couple 100 lines of code, 100 lines of code. Do a code review on that couple 100 lines of code. And then test that couple 100 lines of code integrated into the baseline. So we're not talking about weeks of design, talking about a day or two of design. So this is not waterfall, but the point here is that you break it up into pieces. And so while you are taking those steps down the left side, the activities you're performing can be talked about the same way. And you can imagine that in a perfect world, you would go down this set of green boxes, where when you're in the design step, you're doing design activities. You're in the design review step, you have design review activities, ... And in a perfect world, you would have a design, you look at it, say, oh, I am so good at design, I have no mistakes. And then you would code that perfect design and say, I know my code's really good, but I'm gonna do a review on it anyway. And so you do a review on it and you find nothing wrong, and then you test it and it runs the first time and you say, boy, I'm gonna break my hand trying to pat myself on the back. That's in a perfect world. What world do we live in? Well, before we get into the red area, I want you to realize that by this idea about doing these step by step, like one-way doors, you will not be in this part of the matrix of the box. When you're in the design step, you do just design activities. Before you move to the right, you go to the next step. So you do this stepping down. So you should not be in this area up here by having broken these up into steps. You do one, then another, then another. But let's talk about this red area. You're in test and it doesn't work. You get a 12 instead of a 10 that you're supposed to get, and you go, shoot, something's wrong. So what do? You start looking at your code and you find that you had an algorithm wrong or an equation wrong. And then you recode that equation and you rebuild it. And if it's a really significant change, you would review your code before you rebuild it and run the test again. And now you got a 15 instead of a 10. You go, oh man. And you go back and look some more and you find your design had a flaw. So you had to redesign portion of your design. And if it's significant, so you're dancing around in here. And when you're doing that, you should be logging a mistake. So in a perfect world, you don't leave the green boxes, but oftentimes in your design review, you see a problem with your design, you go fix it, you're over here. In your code review, you see a problem with your code, you review it here. You may find a problem with your design in code review, you fix it here. Testing, I just give you an example. So if you're dancing around the red area, you should be logging a mistake. In a perfect world, you go down the green boxes. And life just isn't like that. All right, so now let's get got enough background here, the words I'm going to use. Let's talk about these 4 pieces to do an effective personal review. All right, so logging mistakes with good descriptions. So I have a picture here that's a screen capture from a tool called Process Dashboard, but you don't need Process Dashboard to be able to log your mistakes. There's a couple of things on here that describe a mistake, and you could do it in Excel. It's simple and straightforward. Here's the most important part of the mistake you're logging: the cause. This is the reason why you had to spend time finding and fixing the mistake. Now, the cause is not the symptom. Like the red light kept flashing when I went under 10,000 feet. That's not a behavior you want, okay? It's not the cure. I had to change line 55 from module XYZ dot CPP. That's the cure. What we want to know is what you did initially wrong in the first place. And so here's an example. I did not properly design the loop termination conditions from the requirements, or I didn't put brackets around my else, or I didn't have requirements for the user interface. It's a mistake you made that caused you to have to go back and fix whatever it was that had the problem. Now, that description is the cause. Super important, and I'll talk about that in a slide or two. There's some other stuff you can log about your mistake, like what kind of mistake it was, or where were you when you made the mistake in your design step or your development steps, whether you're digging a ditch, drafting, or you're writing requirements, or you're writing software, whatever you're doing, there's a set of steps, and where were you in there when you made this mistake? You don't know that until you fix the mistake. So you capture all this stuff at the end after you have found and fixed the mistake. And then another important one under the cause description, okay, is the time it took you to find and fix. Super important that you include the time to find. Dashboard makes it easy because you can turn a timer on pretty easily while you are focusing on trying to find out where the mistake is. But again, you can solve that problem through any tool. And you capture this information in Excel. So these top 3 pieces, they're useful for you when you have a whole bunch of mistakes and you know you can't try to change your process to fix them all. And so you use these top 3 to figure out where should I change my process and which kind of mistakes should I be looking for, because they take the most time to fix. And so all these help you to go through and sift through all the mistakes you have logged to figure out which is the dog that's eating your lunch, because you're not going to try to solve them all, change your process to solve them all at once. So main and most important one is the description, and that it talk about the mistake you made initially. Now, here's some descriptions about the level of detail to put in that description. So highest level, you could say, I made a mistake. Now, you're going to see in the next couple of slides how this is being used, and this is useless for you to come up with a checklist item. You can say, well, what was the mistake I made? I don't know. I just wrote down I made a mistake. Now, you can also be too high level with some details. It says, I typed an equal instead of a double equal. Well, this doesn't help you because you have no context about where you made that mistake. While here, one step down, the green area says, I used an equal instead of a double equal in an if condition. So now you go, oh yeah, I can see that would be a mistake. It would be a problem because it would compile, but it gives the wrong behavior. So there's too little information. And here's enough. Now, sometimes you can say too much information. And by too much, I mean you don't see the pattern. Because one of the things you want to see is that what's happening to me? Where's the one that eats my lunch? And if you make 15 mistakes of the same type, but you have too much detail, you can't see the pattern. So here's an example. I typed sum s or some total sum instead of total sums. That's great, but do we care about whether the word was total sum with an S? No, what we care about is misspelled a variable. That may not take long to fix. It may take a long time to find. And you also have death of a thousand paper cuts. So you want to see that I misspell variables a lot if that's your problem. Here's another one where we have all the function call. It says a function with, I called a function with parameters in the wrong order. And then here it's got the full details of the specific call. Here's the name of the function, here's the order of the parameters, and you say, well, I type this instead of this. Well, if you just back up a step and say, I called a function with the parameters wrong order, this will help you identify that you do it multiple times. You'll see the pattern. I didn't initialize a variable. Instead of I forgot to type as equals 0 after a declaration. Here's all the details. If you have a bunch of these, you may not see the pattern that you are forgetting to initialize your variables. So this is the sweet zone, this just right. Up here, it's a waste of your time to type, and down here at the bottom, you'll have a harder time seeing the pattern. And realize these are your mistakes. Fess up to it, look in the mirror and say, yes, I make mistakes. And start your descriptions with I. They'll help you to write descriptions that explain the mistake you made, as opposed to the tool didn't work right, or the documentation was wrong. Right? Instead of pointing at the tool, point at yourself and say, what was my mistake? I did something wrong. And this is a good way for you to remember what your mistake was. Now, what are you going to do with these things? All right, to summarize, a mistake you're going to log in. A mistake is when you thought you were done with something and you had to go back and change it again. What I call rework. Okay. Now, if you can find the mistake as soon as you've made it, like after you have written the design before you start to write code, or after you've written the requirements before you give it out to your team members for peer review, then you can minimize the rework of fixing that mistake. You're going to make mistakes. The trick is just to find them with the minimum rework. And the fix time should include the time it takes to find where the mistake is and to come up with the right solution and to verify that the fix you made corrected the initial problem. All three of those are part of the fix time. Just like the fix time for that terrible scenario with the pilot trying to drop a stick of bombs. They had to go back in the airplane and try to drop a stick of bombs. Range time, cost, that all that counts as the time to see if your fix really did solve the problem. And last thing, mistake description should identify the mistake that you made, not the symptom. It didn't behave properly in one way or another, not the solution. I had to change this, I had to change that. No, don't care about what you changed. We cared about what was your mistake. I coded the algorithm incorrectly. My design violated the infrastructure for where data goes, whatever the issue is. Okay, now, next piece of the puzzle, creating good checklist items. Drum roll, please. Okay, so here's something that no one at SCI has ever seen before. What do you do? How do you make a checklist item? So a checklist item is a check to ensure you do not repeat a mistake you made in the past. One of the assumptions about this whole idea about having a checklist is that you are a creature of habit. When you make a mistake, you're going to make the mistake again. And so that's what we're shooting for, we're basing on, and we have a lot of data that says, yes, it's true. I teach people this in PSP fundamentals, and the very first program where they have started to do checklists in their personal reviews, they find mistakes. So I see right away, class after class, that sure enough, you make a certain mistake, you will make it again. And this is what checklists are trying to do. So 2 parts of a checklist item. One is where to look in your product, your artifact, where the mistake might be. And the second thing to look for is what should be there. Not if the mistake was there, but if there was not a mistake, what should be there? I'll explain that. Here's 3 examples, but here's the parts. Is where in the requirement would the problem occur, or where in the design, or where in the code, and then what should be there? What should it look like? And so here's some examples. a checklist item might say, else statements should use braces. Declared variables should be initialized. Method calls have the parameters in the correct order. How would you tell that? Well, you would look at the method call you made in your method, and then you would go and look at the actual declaration of the method you're calling to see if you have the parameters in the right order to the way they're declared for that method being called. So you would check it. Some of these are really easy to check. Some take a little bit of time, but still, you're right there. So where to look in your product, whether it's interim product or the final product, and what to look for. And you're looking for what should be there. There should be braces in the else statement. There should be initialized value in declared variables. Okay. Now, how do you translate a defect description into a checklist item? Okay, so with a description, you got to deep dive down. This is done by Booch and Rumbaugh and other people talking about how you do design for requirements. They say find the words and latch onto the words, and that helps you drive whether you need to make new artifacts or new classes or new objects, whatever the topic is, or new methods. And so you say, where in the product could a mistake have been made? And so you look for things like, oh, the else statement. Oh, where in a variable is, or when I call a function. So those are the things you're looking for in the description of the defect. Now, when you say I made a mistake, there is no where. So that's why you want to have more detail. And notice I don't need to know the function name. I don't need the variable name. I just need to know the structure of, in this case, the software. But every shall object should have every requirement statement should have a shall. And that might be the thing is, okay, each requirement statement, is there a shall in there? Yes, okay, good. And so that's the second part. What should it look like if the mistake had not been made? And you're looking for, I forgot braces. And that turns into use braces. I forgot to initialize. Okay, they should be initialized. Parameters were in the wrong order. Okay, so the parameters should be in the right order. And so your checklist item is looking for the right thing. And if the right thing's not there, you found a mistake, but you found it in a review. Much faster to fix than the wrong behavior that it might be causing, and you got a 12 instead of a 10. And now you're diving through the code trying to figure out what the problem is. So the trick is to be specific with both the where in the product and the what you should be looking for. If either one is vague, you're not going to have a good checklist item. It's going to be more difficult to do. And in fact, let's talk about good and evil checklist items. So a good checklist item has specific wheres and whats. Those examples I just showed you. Braces is specific, an else statement. You're going to skip all the declarations, just skip the header completely, and you go right to do a search for a find for the occurrence of else. You look for it, I see braces, next, I see it, next. Oh, there's no braces, fix it. So really simple and straightforward, lots of tools in your advantage to be able to do this. And you solve them. Not all are really easy as do else's have braces, but these other ones are still pretty straightforward. Now an evil checklist item has vague wheres and whats. Examples of that, the code complies with the standards. AV8, one of the groups I worked with for a dozen years, software lead out there, they had 80, 90 coding standards. And say you wrote 100 lines of code. You're looking at all 100 lines of code to make sure it complies with all 80 or 9 coding standards. Forget it. You're never going to come up for air. You're never going to finish this review. What are you going to do? You're going to start thinking about lunch and just call it good and walk away. The logic is incorrect. Okay, or is correct. Make sure the logic is correct. Well, okay, how many ways can it be wrong? Where's your logic? Oh my goodness, every method you have has logic in it. So again, look at all the code and see if it's all right. It's like saying make sure nothing's broken. The loop iterator, so there's something with some detail, works properly. Okay, so how could it not work properly? So here you're looking at specific parts of your product, but you don't know what to look for. I just wrote it 5 minutes ago. It looks okay. You don't have any guidance of how it could be broken. So when you have specific wheres and whats, it's quick and easy to find, to go to the right place and look to see if the right thing is there. When it's vague, you're looking at everything, trying to figure out if everything's okay. And it's just terrible. You just go down a wormhole and you get very discouraged and you start to stop doing reviews. So now, which mistakes in your big log of all the mistakes you've been making should you bother to try to make checklist items from? Well, the ones that cost the most, which are most likely in your testing phases, the ones where you spend the most time trying to fix. And so, so the combination of those two, I would say, if you don't have a checklist, you're doing software. Every mistake you find in testing, put it in your make a checklist item for it, and anything that takes a lot of time, put it in your checklist. Now, there's a design review and code review. So this is where it's important to capture where you made the mistake, because mistakes you made in design, you would put in design review checklist, which is very different than the code review checklist, because you have different artifacts. Where in the design you're going to go look for your mistake? Where in your code are you going to look for the mistake? Very different artifacts, different standards. Now, what aren't you going to make checklist items for? Documentation mistakes. Things like the comments aren't right, or the header isn't right, or the documentation in the header block. Those don't affect program behavior. Don't fill your checklist with administrivia. These do not affect the final product. They might be important, but they don't, it's not worth your time. You're going to get feedback from a peer review. It'll be easy to fix from there. Compiler mistakes. The goal of checklist is not to be a compiler. Your compiler does a great job of that. Now, you may find syntactical mistakes when you're doing your code review. Great, fix them as you find them. But don't put items in your checklist that are trying to do what the compiler will find for you. And lastly, do not put in mistakes made by someone else unless you go, ooh, I've made that mistake before. Great, take advantage of their mistake, put it in your list so that you can find it when you make it. All right, so that's important. You don't want to fill your list with plain compiler or making sure document your comments are right. Okay, just a couple more slides. So using a review checklist with good checklist items. So now you got these 20 checklist items. How do you get them organized? So one of the things you want to do is to get your items that are all related to a certain topic together so that when you're doing your review, which I'll talk about in a second, then you are not doing context switching. So you know, I got a couple of problems I have with the way I name things. So you then go through your code and see, is it consistent? And you go, well, are the names consistent? Are the names within scope? Are the names consistently between header and body? You start to see these problems that you have made, and you're making sure you haven't made them again. And then there's one down here for pointer problems, another one here for calls. And so you don't go back and forth, bounce, 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 bounce. You kind of go through all the items I have with one topic and with another. So it gives you a minimal amount of churn. And I'm already talking about how do you do a review. And the trick is to keep it to one page. You should not try to do everything. You should just have the worst of your offenders on your list. Now, how do you do a review? This is the part that you're going to laugh at. Now, there's some verbiage here, but you're going to see that it's super simple to do a review. So you pull up the product, whether it's a design or a code listing or a set of requirements, whatever it is. Blueprint where you're going to put your trenches in the front yard for your irrigation system. All right, so there it is, and your checklist. So you have a checklist of mistakes you made the last times you generated requirements or made a design or made code or dug ditches. What are the mistakes that you had from all the times you did that? And so you look at the first item in your checklist and you go through your product, say requirements, go through the requirements you just wrote looking for the where in that checklist item, and you make sure the what is there. If you find a where without a what, you found a mistake. And then you're logging it, but you're logging it with a much shorter fixed time than if you had found it later. So when you're finished going through your product for that item, then you go to the second item in your checklist. Go through your product again. Do not try to do multiple items at once. Keep it simple, one item at a time. Go through the dozen requirements you wrote, or the 3 pages of design you wrote, or the 100 lines of code that you wrote. You're not going through 1,000 lines of code, 80 pages of requirements. You're going through small chunks. That's one of the issues here. This is not waterfall. So one item at a time, and then you fix one mistake at a time. You can always make it more optimized later, but keep it simple, keep your focus where it needs to be. Don't try to do the entire checklist at once. So let me give you some examples, and this is where get your chat ready so that you can put some information in the chat. I want to get some feedback from you on how long it takes you to do this. So this is a word search. You've probably seen them, probably not one this big. And I'm going to give you some examples to see how long it takes you to find something in there. So I'm going to highlight the colors of where in this chart you're going to look and what I want you to find. So get your chart, get your chats open, and I want you to say, found it, when you find what I've given you to do. Okay? So here we go. First thing is I want you to find a word in here that has more than 7 characters. Now there's little ones like here's sat and other ones that are really straightforward, but they're too short. So I want you to find one that's more than 7 characters. You're going, okay, Brad, give me some time. Oh, found it. Oh, by the way, Juan, it's in Latin. So now you have a Latin word that's more than 7 characters. So go ahead. Did you really find one? Juan? So go ahead, everybody, take a look. Yeah, verbalize. I love it. Yes, you're right. That's not Latin, though. Okay, Mike found one. It's adorate. I don't know. Sorry, Julia got me. My Latin isn't that good. Well, I'm getting a lot of feedback right away. This is pretty cool. So you can see though that right away you're trying to go through everything, trying to look for a word of more than 7 characters in something that you may not be intimate with. Let's make it a little easier. Okay, so everyone bring your head back up. Now here, I want you to find the word biblicus. And this is like a where's Waldo. So you know now I know what you're looking for. You have a specific what, but you have to go through that entire array of 20 by 20, 25 by 25. So everyone look for it. Tell me when you find biblicus. Yay, Julia found it. Keep going, everybody else. I can tell Julia does this on every Sunday. New York Times. Okay, that's long enough. So where is it? Sure enough, it's right there, upside down. Can you make it any harder, Brad? All right, so we've got a specific what, but the where was everything, right? Let's take another one. I want you to find Veritas. But by the way, it's in the bottom half of the search block and it's backwards. So find it. Tell me you found it when you find it. Everybody. Good. All right. Great. Got one. Keep going. Give me some feedback. Anybody else? Julia found it, but she doesn't want to say it. You still found verbalize. Stick with it. Okay. Well, here it is. It's down at the bottom in the center, going backwards. All right, so I gave you a more specific. And so uh, Lansing found it faster than if I told him find it everywhere. I actually told him backwards. He probably looked for sat. So he's going through the bottom looking for sat, found sat, and looked to see if the rest of it's there. Now, I'll give you one more. Here's Paranus. And by the way, it's in the leftmost column going down. Tell me when you found it. Now I'm going to see who's actually watching my presentation. How could you guys find it so fast? Get out of here. Now, wasn't that easy to find when I told you exactly where to look? Now, imagine if I was asking you, see if I spelled biblicus right. See if I spelled veritas right. See if I spelled paranus right. And sure enough, it's right there. It's a lot faster to find those words to see if I did it right, if I tell you where to look in this mess of all these letters. And that's the benefit of having a specific where to go with a specific what. So I gave you 3 words that were specific, And one of them you had to look everywhere. Another one you had to look in part of it in a certain direction. Last one told you exactly where to go look down to the column. And you found it tons faster than the other times. And that's why a good checklist item rocks on making your personal reviews go so quickly. So review this section here. So checklist items are built by picking and identifying where in your artifact would the mistake be and what would it look like if it was right. And you get that from the mistake descriptions. So you got to have good descriptions. And the more specific the where and what are, the more rocking it's going to be to quickly it is to check that item and to verify, to find that item where it is in the product or artifact and verify whether you made the mistake or not. You don't want your checklist full of trivial things. You want the expensive mistakes on there when you're creating your items, and then group them together so you have all the, for example, pointer mistakes together, all the function, the method call mistakes together, all the variable declaration mistakes together, so you can keep your head straight and have some kind of cognitive non-dissonance when you're going through and doing your review. And when you do the review, one item at a time, go through the artifact, seeing if you made that mistake. So, any questions?
So, Steve, you wanted to unmute and say your comment?
Oh, Brad, I just made observation that although a few of the pointers that you mentioned are specific to personal reviews, it seems like many of the concepts would be equally applicable to creating checklists for peer reviews.
Yeah, the major difference would be that what are you looking for, and in personal reviews, the focus is on the mistakes you make. And peer reviews, you could use your list of your mistakes to look at someone else's.
Or,
be
Brad,
fast.
what you could do is like, so one of the things we always say is like, if you find a defect, then look for the similar defect in similar places. So like we always say, look for similar defects, but if you say are specific, like you find something in an else statement or something like that, then you know to go look and make sure there's parentheses on all the else statements or whatever it is. So that could be good for peer reviews.
Yeah, now at AV8, we had just like there are certain standards that AV8 software had to be rewritten to because they were like the third rail. You didn't want to do that mistake because it caused the software in the aircraft to go very badly in flight. And so there were certain things you just never did. And so there would be, everybody should check for this mistake. And so everyone's checklist would have, hey, make sure that they did garbage collection of dynamic memory allocation properly. And
Yeah.
that everybody was tasked to look for that. So it never got by everybody. And so there were items that everybody would look for.